This is just a sample of the training available at itdvds.com. To see complete training, please go to itdvds.com. Let's begin the sample. Okay, let's go over the whole encapsulation process step by step. Here we have computer A, and let's say computer A is trying to make an HTTP request to computer B. We can see computer A's IP address is 192.168.6.100. The subnet mask is 255.255.255.0. We haven't gotten into subnet masks yet, but basically what this says is that any IP address between 192.168.6.1 and 192.168.6.254 is in this computer's subnet. The default gateway is 192.168.6.1. Basically, we use the default gateway if we're trying to contact a computer that's not in our subnet. And the MAC address is 00-11111111. And that's not a real MAC address. I'm just making this one 11111, this one 222.222.33333, just so it's easier to read. Although this is the correct MAC address format. So now computer A is trying to make an HTTP request to computer B, whose IP address is 192.168.8.200. So computer B is in a different subnet than computer A, and we can also see that computer A is behind a router, so it's in a different broadcast domain than computer B. So the first thing computer A is going to need to do is figure out computer B's IP address. And it's going to query a DNS server to do that. So it's going to say, hey, DNS server, what's computer B's IP address? The DNS server is going to come back with 192.168.8.200. So now computer A knows that, okay, computer B is not in my subnet. If computer B was in my subnet, I would send out an ARP request to get the MAC address for computer B's IP address. But since it's not in my subnet, I know that I need to send this frame that we're going to create over to our default gateway, which is 192.168.6.1. But I need to get the MAC address of 192.168.6.1. To do that, computer A is first going to look in its ARP cache. And let's take a look at that real quick. Okay, I'm on computer A, and I'm just going to open up a command prompt. And I'm going to type in ARP -A. And this is actually going to show this computer's ARP cache. And we can see that 192.168.6.1 is in fact cached. So in this case, desktop A would not send out an ARP request to figure out 192.168.6.1's MAC address because it already knows it. And this is a real example of a MAC address. In our diagram, we're just going to use a fake MAC address just so it's easier to look at. And in our example, we're going to act like the MAC address is not in the ARP cache of desktop A. So let's go back to our diagram. So computer A looks in its ARP cache, and again, in this example, doesn't have the MAC address for the default gateway, which is 192.168.6.1. So it needs to actually send out an ARP request saying, hey, what's the MAC address for 192.168.6.1? It's going to send that out. Remember, an ARP request is a broadcast, so it's going to go to all hosts on our subnet here in our broadcast domain. And our router, this interface on our router, FA00, is just fast Ethernet 00 port. We're going to talk about that in a little bit, but it's this port on the router is going to see, hey, I'm 192.168.6.1, and I know my MAC address. It's 00.222.222. So it's going to send that back to computer A. So now computer A knows the default gateway's MAC address, so it can start to create the packet and the frame to make its HTTP request over to computer B. So this is going to be step one here. Computer A sends a PDU, and PDU is Protocol Data Unit. So we're going to go down the OSI model here. So layer 7, 6, and 5. We're on computer A, we open up Internet Explorer, and we type in http://computer B. Now we've already gone through the DNS process and the ARP process. So we're going to make our way down to layer 4. And layer 4 is where the encapsulation process is going to begin. So remember, this is a segment, and we're going to tack on a header here for a source port and a destination port. Well, we're making an HTTP request, so the destination port is going to be port 80. And we're going to be using the TCP protocol. We'll get into that a little bit more, but that's going to be a generated number that's over 1024 or 1024 and above. So in this example, I'll just make it pick 20,000. So the segment's ready. It's going to be passed down to layer 3 to become a packet. And here it's going to add the control header. We're going to need a source IP, a destination IP, and a protocol. Let's go back and look at our diagram. Well, we know the source IP is our IP, which is 192.168.6.100, and we figured out the destination IP address through DNS. It's 192.168.8.200. So let's go ahead and add those. Add our destination IP address. Okay, we've added our source IP and destination IP. The next field is protocol, and this lets IP know what protocol has been encapsulated. And that's actually going to be the TCP protocol because we're making an HTTP request. But again, we'll get into that a little bit more. But the protocol numbers are actually standardized, and this is actually the hex value, and we're going to talk about hexadecimal in a little while too. So that's not important right now for the encapsulation process. But now we have our packet. So next, it's going to be passed down to layer 3, or layer 2, and we're going to create a frame out of that packet. Okay, we've created our packet, and let's pass it down to layer 2 to make our frame. So we'll pass it down here, move all these values down. And in our case, we need the destination MAC address, which is going to be our default gateway's MAC address, and the source MAC address is going to be our MAC address. Let's go back to our diagram and take a look. So we figured out that, okay, computer B's IP address is not in our subnet, so we need to send this frame to our default gateway. So we're going to be using the destination MAC address of 00222222, and we figured that out with an ARP request. And we know the source MAC address is us right now, which is our MAC address 00-111111. So I'll go ahead and add our destination and source MAC address. And also in our frame header, we're going to need an ether field value, and this tells layer 2 what protocol has been encapsulated, so what protocol our packet was using. And remember up here there was a protocol field that told our layer 3 what segment the protocol was being used. In our case it was TCP, so we use 0x06. Now for our packet, it's using IP version 4. So all these numbers are standardized for protocol and ether field. And IP version 4 is 0x0800. So this is again a hexadecimal number. We'll talk about this later. It's not necessary to memorize the ether field and protocol values. So this is just our example. And also at the end of our frame, we're going to add FCS, which is a frame check sequence so that error detection can occur when this frame reaches its next destination, which is going to be our default gateway. So now this frame is ready to be broken up into bytes and bits and sent over layer 1, which is our actual Ethernet cable. So the bits and bytes are processed 100, and you can see all the bits. Now let's go over to our diagram. So step 1 is done. We're sending our bits over, and they're going to hit the switch that computer A is connected to. And the switch is actually going to take a look at the frame and see what the destination MAC address is. Because remember, a switch works at layer 2. So a switch is going to get all these bits, assemble them, or reassemble the frame, and look at, hey, the destination MAC address is 00222222, and then the switch is going to look in its MAC address table to see if it knows which port to send it out, to send this frame out on. based on the MAC address. If the switch has the destination MAC address in its MAC address table, then it knows which port to send it out. So it's going to send it out this port, and then the frame is going to make its way over to our default gateway. So this port on our router. Now, if a switch doesn't have the MAC address, the destination MAC address in the MAC address table, then it's actually going to send that frame out all ports on the switch except for the port that it came from. So it would send it out all ports, and of course including this port, and then the frame would reach this port on the router. So either way, it's going to reach this port on the router. As a little side note here, a switch adds MAC addresses to the MAC address table when the source MAC address comes through the switch. So if this router ever sent a frame to this switch, then it would know its source MAC address, and therefore would know which port to send our frame out, because it know, hey, I got a frame from 222222 on this port, so I know I need to send any frame destined for that MAC address out that port. So now we're on step 2. The router receives the PDU. So now the decapsulation process is going to happen, because the router is going to get this frame. It's actually going to get bits. It's going to reassemble them into our frame, and then it's going to strip off this layer 2 header, because it sees it is the correct destination. So it's going to strip off this header. Let's go ahead and get rid of this header, which will leave the packet. And it's going to see, okay, the destination IP address is supposed to be 192.168.8.200. Do I know where that network is? And it's going to look in its routing table. And we'll talk about routing tables in depth later on. But basically, a routing table is going to tell what port this packet should be forwarded out. And this routing table says it should be forwarded out of our IP address 192.168.6.1, MAC address 00333333. So it's going to forward it out fast Ethernet 01. And its routing table is going to know where to forward it to. In this case, it needs to forward it to this router on this Ethernet port, fast Ethernet 00, with the IP address 192.168.7.2 and the MAC address 00444444. Now, if this router does not know the MAC address of this port, then it will actually send an ARP request as well. So it would repeat that whole ARP process to find the MAC address. So now we're at step 3. We're going to re-encapsulate this frame. So our packet's going to stay the same. This is going to be untouched. The source IP is still 192.168.6.100, and the destination IP is still 192.168.8.200. But we're going to reframe this. And because we're sending it out this port, our source MAC address is going to be 00333333. Our destination MAC address is going to be 00444444. So let's go ahead and add those. And we're still encapsulating IP version 4, so our ether field is going to be the same. And this frame is going to be converted into bits and sent over the wire. So it's traveling over the wire, and now it gets to step 4, where the router receives the PDU. So now we're on step 4, where this router is receiving the bits that were sent from this router. And they're being received on this port. So that port's getting the bits. The router's going to reassemble the frame and see, hey, the destination MAC address is 0044444444. That's my MAC address. So this frame is destined for me. So now it's going to strip off the layer 2 header. It's going to start the decapsulation process. Let's go ahead and strip it off. That's going to leave the packet. And it's going to take a look at the packet, say, hey, what's the destination IP address? It's 192.168.8.200. Do I know where that network is? And in fact, this router does. It's going to look in its routing table, and it's going to see that that network is actually directly connected to this router out this port. So the final destination for this packet is on the same network as this port. So therefore, the router knows that, okay, I need to send this packet to 192.168.8.200. Do I know the MAC address for 192.168.8.200? It's going to look in its ARP cache. If it does know it, then we're in good shape and we can reframe it and send it off to computer B. If it doesn't, it's actually going to do an ARP request. So it's going to send that ARP request out, say, hey, what's the IP or what's the MAC address for 192.168.8.200? ARP is a broadcast. Therefore, it's going to make it over to computer B. Computer B is going to say, hey, my IP address is 192.168.8.200. Here's my MAC address, 00666666. It's going to be sent back to the router interface, and then the router is going to know the MAC address of the destination for this packet. So let's reframe it. When we reframe it, we know the source MAC address now, because it's going out this port, is going to be 00555555. The destination MAC address is 00666666. So let's re-encapsulate this packet. And the packet is still IP version 4, so the ether field is going to stay the same. This frame is going to be turned into bits, passed down to layer 1, and sent over the wire. So the bits are now going over the wire. They're going to hit the switch. The switch is actually going to look at the frame, say, hey, what's the destination MAC address? Okay, I see it's 066666. Do I have that in my MAC address table? And let's say yes, I do. Now it's going to send it out this port on the switch. So it's going to forward that frame off. And the bits are now coming down. And now we're on step 6. Where computer B is actually receiving the PDU. So computer B gets these bits, reassembles them into a frame, and sees, okay, hey, the destination MAC address is for me, so this frame is mine. It's going to strip the frame header off, which leaves the packet. It's going to look at the packet, say, hey, the destination IP is 192.168.8.200. That's my IP address. So it's going to strip off our control header. Now it's going to look at our segment and see that, okay, the destination port is port 80, which is HTTP. And that tells it where to hand it off to on layer 5. So it's going to pass it now up to layer 5, and it's going to strip off the header here and pass it off to the correct protocol in layer 5. And now it's just data. So it's been completely decapsulated, and this protocol data unit has reached its destination. And most likely it'll be a web server, and then that web server will send information back to computer A. And the process will just repeat itself. So this was kind of a long example, but it's great to see the process from end to end. And it's very important to know for the test and in the real world how this exactly works. Because we'll need to know, hey, if computer A sends information over to computer B, let's say, what is the MAC address or the source MAC address on the frame that computer B receives? Well, in this example, we saw the source MAC address was 5555555. One might think that the source MAC address would be computer A's MAC address, which is 11111, but we know that's not the case. We might also get asked, hey, what was the source IP address on the packet that computer B received? Well, the source IP address never changed. It was, in fact, 192.168.6.100. So those are some questions that we need to know the answers to.